In past videos, I documented the process of creating some Pokemon NFTs using smart contracts and then viewing those Pokemon NFTs on OpenSea. Today, I'm going to take a step back and explore the main points of EIP 721, which describes what NFTs actually are. The word fungible describes objects that can be easily replaced by similar objects, for example, dollar bills, gold bars, or bricks. NFTs are non-fungible tokens, which means that these kinds of fungible items are not suitable for NFTs. Non-fungible tokens instead describe things that are unique, such as a house or artwork such as the Mona Lisa. In this screenshot from Google Maps, every building has a number on it. If these numbers are unique, then we can simply associate each number with a unique NFT. NFTs can also represent virtual land. Projects such as The Sandbox and Decentraland are using NFTs for exactly that purpose. If we continue with this analogy of NFTs representing land, then we could have a representation like this, in which each NFT has a token ID, 1, 2, 3, or 4, and it has an owner, Alice, Bob, or Charlie. Each token is tied to an address or a plot of land. To put this in more technical terms, every NFT has a token ID and a token URI. By visiting the token URI, you can see all the other properties of that NFT, which we call metadata. In the case of a property deed, this would include information such as the address, a photo of the property, and also the year that the property was constructed. These token URIs and metadata are also described in the ERC 721 standard. We have a token URI for a given asset. The token URI can refer to metadata in JSON format that describes the properties of that token, such as a name, a description, and an image. NFT platforms such as OpenSea depend on the token URI to display metadata about that NFT. If a token conforms to the ERC 721 standard, then platforms such as OpenSea know that they can work with those tokens and retrieve the metadata associated with that token. OpenSea expands on the metadata standard by allowing users to pass in more properties about their NFT. For example, image data, external URL, description, name, attributes, and background color. When I created the Pokemon NFTs, I stored the metadata on IPFS and then created a token URI for each Pokemon NFT. For example, by opening this token URI, we can see the metadata that I created for Bulbasaur. Its name is Blockchain Ball Bulbasaur. It has a description. It has attributes. For example, it's a grass type, its HP is 45, its speed is 45, and it also has an image. The creation of NFTs is called minting. The term minting comes from the creation of metallic coins, which are minted in a mint. To create an NFT, you basically pass in a token URI which contains the metadata for that NFT. The smart contract will then create a new token ID and then associate the token URI with that new token ID. The smart contract that I used to create the Pokemon NFTs demonstrates these steps. The method to mint the NFTs takes in the address of the recipient and the token URI, which points to the metadata about that NFT. I create a new token ID by incrementing the token IDs +1. So this means the token IDs are being generated in a sequentially increasing order, for example, 1, 2, 3, 4, 5, 6. The mint method creates that NFT using the new token ID, and then I'm basically associating the token URI with that new token ID. It really is that simple. The ERC 721 standard also describes how NFTs can be transferred. Transfers can be initiated by the owner of an NFT, an address that the owner has approved for transfers, or an authorized operator, which basically has control over all of the tokens of that owner. In the case of decentralized apps or wallets that are controlling your NFTs, you're basically giving that entity permission to transfer all of the NFTs on your behalf. That wallet or exchange is an authorized operator. There are many optional features that are not described in the NFT standard, and new ones are constantly being created. For example, soulbound NFTs are NFTs that cannot be transferred. Once minted, these NFTs are always going to be tied to the original address that the NFT was minted to. Burning refers to the destruction of tokens. Not all NFT smart contracts allow for burning. For example, the Bored Ape Yacht Club smart contract allows you to transfer NFTs, but does not allow you to destroy them. A smart contract that implements the enumerable interface allows you to find all the tokens that belong to a user. Some NFT contracts are also pausable, which means that the owner of the contract can pause the NFT and stop NFTs from being minted. OpenZeppelin provides a ton of different open source contracts that you can use to build your NFTs. We can see that they've categorized their smart contracts into core and extensions. These core contracts represent the contracts that are most important and most commonly used by NFT smart contracts. For example, metadata allows you to associate a token URI with a token. Enumerable allows you to find all the tokens that belong to a user. By implementing the receiver extension, a contract can show that it's designed to receive and work with NFTs. The extensions section shows optional extensions that provide a lot of cool functionality, but that are not required by the ERC 721 standard. For example, pausable allows you to pause the contract and prevent people from minting. Burnable allows you to destroy tokens. URI storage allows you to store the token URI on the blockchain itself. I have videos explaining each of these extensions, which you're welcome to watch. If you don't need all these fancy features in your NFT smart contract, then you don't need to include them. The more features you include in your smart contract, the more expensive it is to deploy, and it's also more expensive for users to interact with your application because this extra functionality consumes more gas. Therefore, you should first carefully analyze what functionality your smart contract needs, and then you can mix and match to get the right bunch of features that your contract needs. If you enjoyed the video, please give a like and subscribe, and I'll see you in the next one.